This short video is intended to demonstrate how to start up an HPLC and using the ChemStation software. This is an Agilent 1100 HPLC. So in this I am online now with this software. I switched on the instrument, so the software recognized all the instrument parts, the injector, the pump system, the thermostat with a column. I have a diode array detector here and is ready to integrate any peaks. So how I would start my analysis or HPLC setup with the ChemStation. First, you can see I have a quaternary pump system. I have got in this method three solvent system, solvent bottle. So first, I would like to ensure that I enroll here how many actual volume of the solvent I have in each bottle. I have 1 liter bottles, so I set up solvent B. I have this is solvent B is almost full, and solvent C. Oh, sorry, you see it says that I have to tell the instrument that it is a 1 liter bottle, and for solvent bottle C is also a 1 liter bottle, and I have only 0.5 liter of solvent. That is an approximate what you need to say, and then you click here prevent analysis if level falls below 0.1 liter, and then turn the pump off if running out of solvent. This is a very good safety measure. You see now is all showing how full are my solvent bottles, because if I run, I have an auto sampler, and I run lot of samples. I go home, and when it's finishing the analysis it stops usually. However, if I happen to run out of these solvents, it also stops the HPLC, so it will not pump air through my system. So when we set up this bottle, so I know I have got the column inside, the detector, everything is ready, and my bottles contain the appropriate solvents, then I can switch on the system. To get ready for the analysis, we have to know that which solvent we are starting. My solvent C is the buffer usually, and B is the acetonitrile. Solvent A is also a buffer, a pH 2 buffer. I use pH 7.4 buffer in solvent bottle C, and the D I usually use high pH solvent because I measure lipophilicity and retention time using various pHs and gradient system. So you can see and you can hear my pump started to pump this. Now I don't have any column at the moment for this demonstration. That's why you can see the back pressure is not high. So I just would like to show you how to start and set up a method. So edit the entire method information, instrument acquisition, data analysis, and runtime checklist. So here the method comment, you can tell anything, a title of your method, so you remember, and you can put it into your notebook. This is a C18 column reverse phase analysis, 5.5 minute runtime is a gradient run. And then when you click OK, then it shows the pump setup. Here you can change the flow rate. Now because I don't really pump through the column anything and want to save solvent, I just want 0.5 ml per minute. I hope I will not overwrite my method. The stop time 5.5 minutes, and I I started now pumping 100% solvent from my bottle C, which is a 7.4 pH 7.4 buffer, and my bottle B contains the acetonitrile. And here is the gradient profile. Here you don't need to write everywhere 1 mil. If you write here 1 mil is the flow, but I need to change now 0.5 mil, don't forget. So your starting flow here and here should be the same. And then in 3 minute time, the pump will start pumping 100% acetonitrile, mobile phase B, but it is a linear, continuous, nice increase. So not all of a sudden from 0 to 100, but changing continuously. So within 3 minutes, it will reach the 100% B solvent. It keeps that to elute everything for 1 minute. It goes back quickly and start re-equilibrating the column with my buffer for the next analysis. So this is how you set up your gradient profile. If you don't have gradient, you can delete this highlighting and you can cut. You see, go here to cut and then you delete the lines. Or if you want to insert more gradient steps, you just put an insert line and then you can delete this line. So now I cut it. And then when you are happy, you say OK. And what I do, here is the injection. You could hear that my pump started to pump lower flow rate, so it's less frequent clicking. Here I use here a standard injection with 15 microliter of the volume, but you can insert a needle wash. Then you have to put a washing solvent in a certain position of your autosampler, and you will see I put 99, it will be here, it will appear here, and then the software will instruct the instrument to wash the injector after every injection using the solvent which is in vial 99. You can change here. Next, I said okay. Next will be the UV signal. So I set up to 254, 250, 210, 230 and 220. For this analysis, I used this method last time for low UV compounds. Is actually from a nice food spray oil. I wanted to detect how much mu oil, lemon myrtle, and isopropyl myristate is in my product. So I needed to monitor as low wavelengths as possible. Then you set up the thermostat temperature is 30 minutes. I have a column switch. I just use here you can set up which column you want to use. I can put 2 columns in my HPLC system. So when it finishes one run, this valve will switch to the second column and finish and runs again the samples on the second column. So I say OK. Here are the signals. You can add where the signals or the pressure, what you want to monitor, and it will be recorded at the end, and you will have chromatograms using these 5 wavelengths, and you can even record, you see, the solvent composition on your chromatogram at that moment when the peak comes and so on. So you say OK, and then here are the integration events. I don't go too much in these details. I use the default method, but you can here reject very low peaks, so it will not integrate everything, even some noise or height rejection, or when should the computer sense that the peak is starting. This is the slope sensitivity. The higher is this value, the later it will start to integrate your peak. So I keep it in the default. Is usually the engineer will set up for you for the default, and you don't need to change it unless you observe something which is not right on your chromatogram. And then here is where you can define your reporting style: short, detailed, with a header, with GRP report or full report, and so on. I usually just have the short report, but you can do the detail, which will give you the integrate thing, the peak area values as well. I always like to see the chromatogram, so I take the chromatogram, the sample info, and the table of the peaks and peak area, peak height, and peak width. And file, I want to keep this report. I like to see on the screen. If I'm here, I can check, but definitely I have to take the file. If you connect it to a printer and you have enough paper in it, you can print every chromatogram. I like the PDF as well. The CSV file is very useful to keep the chromatogram and the report in CSV form, because that you can put it in Excel and you can use it to redraw your chromatogram, beautiful high quality chromatograms, and not just what the instrument, the ChemStation, provides you in PDF. So this is the screen, and then here what curves you would like to have on your chromatogram: flow, temperature, pressure, and so on. I usually don't have those. And standard data acquisition, here I have a macro. Sometimes I use this instrument to measure lipophilicity of the compounds, which converts the major peak retention time to a lipophilicity value. And you can see that in my system I can inject 99 compounds in one run, and then I don't want to look up each 99 chromatogram and write down manually the biggest peak retention time. So this macro, for example, it exports the biggest peak retention time to an Excel file. So when I finish the analysis, I have the not typed with potential typing error, but computer generated Excel file with the retention time of the major peaks of the chromatogram. I still usually check the chromatograms as well, but at least I don't have to type. So here you can add some macros if you have got, and that's it. And then don't forget to save the method. Now I don't save it because I changed a bit of this method out of my normal analysis time. So you can see when it's all green, practically you can start the chromatography. However, you have to tell the computer how many samples and what samples you want to inject. So we go to the sequence tab, sequence parameter. Here we have to, I just put here test, define the file where the results will be found after the analysis. So it will be usually ChemStation 32, 1 data, and then a file name. And you can define here whether automatically count injection 1, 2, 3, or you can signal counter. You can set up. Now in this window, the most, so this is the sequence and the first line of the sequence table. The most important is to put this post-sequence common macro, which means you can see macro shutdown. Here are several built-in macros. Doesn't yeah, okay, yeah, I have to check because I put this test analysis, pump off, a lamp all off, or standby. So when it finishes the analysis, it will stop the instrument, stop the pump, stop the recording, switches off the pump and the detector, which is good because if the this long run finishes in the middle of the night and I come next morning, I can ensure that the instrument is switched off and didn't pump. Also, here you can put a not ready timeout, 10 minutes or 1 minute, or you can change. Here is 5 minutes. If something goes wrong, if the injector couldn't find the wires, for example, or something went wrong and the instrument is still pumping the solvent, but the analysis is not ready, the instrument is not ready for the next analysis, then after 5 minutes it will switch off, which is also a good safety feature. So this is important with the sequence file. And the next most important thing is the sequence table, where I tell the instrument what samples I am analyzing, in which vial, what is in the vial. You can type here, you can insert, you see if you come here, insert more rows, or now you can cut or delete, you can copy and paste, you can append line, you can insert. If you insert a lot of vials, you can tell the insert or append location is, let's say, 7 to 99. Number of lines to insert, let's say I put just 60. Here I can give the method name. I will C18 faster method. C18 faster is a longer gradient for this MU-oil myristate ethylhexyl palmitate. I wanted to analyze a food spray composition here. And then injection, how much you want. You want one injection or twice. Let's say usually I inject twice from the same sample just to ensure and is a sample. And then I say okay, and look, it filled up my file, my template. Obviously it didn't put the name. I have to import or copy here the name, and you can see 2 injections from each vial, and it goes up to 60 more samples, which is 66. I say okay, you can start running the sequence here, but actually I don't save okay, because here you can tell how many injections per vial, and also at the end you can override the injection volume. Let's say you realized, oh, this 15 microliter, what I said in the method file, is too much and I want to change it to 5 microliter. This will override the method volume. And then I say okay, and then I am ready for the analysis, you see, sort of, and I say on. And then unfortunately you see, my method sequence file said a fastel method, a longer gradient, so it will switch when you have to press the start button and change. I don't change that, and look, it filled up all my vials, what I just showed you. And now when it's blue is working, so now my system is starting to inject. It also checks the diode array detector is yellow, which means it zeroing out and checks everything is okay. And when it will get green, now you can hear my HPLC started the injection. So this is a short video how to start a run and what are the most important files, method and the sequence. And here, when instrument, you see, you can just change and see the pump. You see, I use a different method, not what I set up, because in the sequence I use that, and this is another method, and that is what currently my instrument is running. And here you can put more pump, actually is a very useful, and you put a single wash. You can do it while the instrument is running. This single wash, it washes the pump pistons on the back. I usually do it before the run and after the run to ensure that the buffer and the salt will not crystallize out in the piston. So that's all. Now I stop recording.